Let's go ahead and get started on currents. Now, the first thing we're going to talk about is electrical potential energy. This is the ability to move an electric charge from one point to another. Just like we talked about potential energy last unit, that was the potential energy we said has the potential to be able to move. That's the same thing here, except it's just with electric charges. Now, potential difference is measured in volts, and that's just the difference, like almost the measurement of how far it moved. Now, the potential difference is the change in the electrical potential energy of a charged particle. So how much did that charged particle change? Now, voltage is what sets charges in motion. And there is a voltage across terminals of a battery, and that's called a cell. Now, most batteries are electrochemical cells, meaning they convert chemical energy into electrical energy. And we've talked about that actually in our energy unit also. We talked about that if we have something that uses batteries, that it's taking chemical energy and turning it into transforming it into a different type of energy. Now, current is the rate of charge movement through a wire. So it's how fast electric charges are moving. Current is measured in amperes, and the way we shorten amperes is with an A. Now, a battery is direct current, and we're going to talk about alternating current in the next couple of videos or so, and so you're going to have to tell the difference between direct current and alternating current. So let's talk about direct current now. Direct current is when charges always move from one terminal to the other in the same direction. They constantly move in the same direction. If you look at the pictures below, you'll see the arrows pointing for the battery, and that they're always going in the clockwise. For this picture, it's clockwise, and it would never change to another direction, and that's direct current. Now, batteries such as like Duracell or Energizer that we put in our remotes or put in flashlights, they are dry cell batteries, and that's because they contain a chemical paste on the inside. Now, car batteries, or something like batteries that you put in a golf cart or four-wheeler, something like that, they're called wet cell batteries, and that's because they contain water on the inside. The water is actually used to conduct electric current. And so those are the difference between dry cell batteries and wet cell batteries. And again, voltage is what sets charges in motion, which we had already said that previously. Now, let's look at electrical resistance. Resistance is caused by internal friction, and just like the word resistance in the English language, it slows down something. And so electrical resistance is what slows the movement of charges through a conducting material. So for instance, we talked about this last video. Copper wire are conductors. They're going to not have a very high resistance. Their resistance is going to be low, and it's going to allow charges to flow freely. An insulator is going to have very high resistance because it really slows down the movement of those charges. Now, resistance is measured in ohms, and this is almost like a little horseshoe symbol is what we use to symbolize ohm. And the resistance, like for instance, this is an example for you, the resistance in a filament, in that light bulb picture, the little squiggly line that goes across, that's the filament, and the resistance of a filament determines how bright the light bulb will be. And we can actually calculate resistance. We can actually calculate resistance if we know current and voltage. Now, this is very important for us to look at. This tells us our equation, but also we need to know how voltage, current, and resistance relate to one another. Now, resistance is found by dividing the voltage across the conductor by the current. And this equation is known as Ohm's law. So Ohm's law is voltage equals current times resistance, or V equals I times R. You need to make sure that you know voltage equals V, current equals I. We said that current is measured in amps. It is. It is measured in amps, but the symbol for the formula is always I. And you've got to know that. So you may want to jot that on your notes, that voltage equals V, current equals amps, A, but also equals I in the formula, and then resistance equals R in the formula, but it's measured in ohms, which is a little horseshoe looking symbol. Now, I want you to look at these pictures. On the picture on the left, we have a very low resistance, so that gives you a very small R, but your I is larger. That's showing you that as you lower resistance, your current increases, okay? And if you look over at the picture on the right, you've increased your resistance, the R gets larger, and you're decreasing the current. That's how these are related to one another. So make sure you've written down your equation, your voltage equals current times resistance, the V equals IR, that you've written all of the symbols and what they stand for, and that go ahead and pause the video and draw your circle so that you have it ready. Now, we've already talked about this, but conductors have a low resistance because charges flow freely, there's not much resistance there. Insulators have high resistance, that's what's slowing down the electric charges from moving. And then semiconductors are going to conduct electricity only under certain situations or certain circumstances, so not in every situation. Now, some materials can actually become superconductors. That means that they conduct very, very well, better than a regular conductor. Now, one use for this material is actually a new type of train that they are coming up with. I don't believe it's in use yet, but they're actually using electric charges and magnetism to levitate this train. So it's almost like the train and the bottom of where the train would normally sit start to repel each other once the coils and the electric charges start to travel, and they repel each other, so it almost levitates, and that's how it would travel. They say that they believe this would obviously cause a better ride, but also possibly a quicker ride because there would not be the friction between like train and tracks. So this is just one idea that they've been using superconductors for. And that ends our video, but it doesn't, it ends our slides, but it does not end our video. We have got some practice problems to do for calculating resistance. So let's go ahead, we're going to do one practice problem together, and then I'm going to let you practice 3 on your own. All right, I had told you to pause the video earlier and write all of these things out, but just in case you didn't, V equals voltage, and voltage is measured in volts. I equals current. Current is measured in amps. And R equals resistance, and it's measured in ohms. Okay, now let's draw our circle. We had already said that voltage equals current times resistance. So let's draw our circle. Hopefully you already have, and I messed up royally on that circle. So let's draw our circle, and hopefully this is just checking yours because hopefully you did pause the video and draw it earlier. It's a pretty sad looking circle still, huh? All right, let's go. We've got I and R are next to each other in the formula, so they have to be next to each other in the circle. So this will be the circle that we use. Now let's read this problem together. Find the resistance, so it's already told us, R equals question mark. Find the resistance of a portable lantern that uses a 24-volt power supply and draws a current of 0.8 amps. So we have the voltage equals 24 volts. We have the current equals 0.8 amps, okay? And so we're going to say R equals, if you cover up the R, that gives you V divided by I. Okay? So then we'll fill in our numbers. R equals 24 volts divided by 0.8 amps. And once you put that in your calculator, you get 30 ohms. And that's your resistance for this problem. Now this is what I'd like you to do. I want you to pause the video, and remember, you're just shorting yourself and you're not finding out for yourself if you have questions if you don't do this. But pause the video, do numbers 2, 3, and 4 in your notes, resume the video when you're ready to check your answers. All right, very quickly, this is number 2. The answer is 240 ohms. Okay. The next one that you had was number 3. The answer was 6 volts. And your next one was number 4, which was 0.43 amps. Now, if you got all of these correct, go ahead and do your summary, and this is what I want you to do for your summary. I want you to write out the relationship between voltage, resistance, and current. Tell me how they affect one another. Write that relationship out as your summary, and then go ahead and close out your video for today. If you got these wrong, go ahead and keep the video on because I'm going to go through these. Now, number 2, it says the current in a resistor is 0.5 amps when connected across a voltage of 120 volts. What is the resistance of the resistor? So again, it's asking you to find resistance. 0.5A, that gives us current. Remember, current equals I in the formula, but it's measured in amps. And then we have volts, which is 120 volts. Now, R, let's go ahead and draw our circle again. We have I and R together and V by itself, or next to each other, and V on top. So we have R equals V over I. And when we fill in our numbers, it's 120 volts divided by 0.5 amps. And once you put this in your calculator, you're going to find out that the answer should have been 240 ohms. Now, remember, if you got it wrong but you did the equation right, remember that you always put in the top number on the formula first in your calculator. So you should have put 120 divided by 0.5. Now let's look at number 3. Number 3, let's go ahead and draw our circle. Again, just so that we can have it and look at it. The current in a video game is 0.5 amps. If the resistance of the game's circuitry is 12 ohms, what is the voltage of the battery? It said, what is the voltage? So that's our question mark. The first number is 0.5A. So we have I equals 0.5 amps. And then our next number is 12 ohms, and that's resistance. So let's go ahead. V equals I times R. Let's fill in our numbers. 0.5 times 12. And so voltage for this one is going to be 6 volts. And let's go to number 4 to make sure you understand it. Number 4, let's draw our circle again, which you should have this in your notes, but just so that we can see it on here also. Oh, I did something wrong. Okay, a 1.5 volt battery is connected to a small light bulb that has a resistance of 3.5 ohms. What is the current in the bulb? It says, what is the current? So that's our question mark. Voltage equaled 1.5 volts and resistance equaled 3.5 ohms. So I equals, if you cover the I up, you're going to see that it equals V divided by R. And let's fill in our numbers for that. 1.5 volts divided by 3.5 ohms. So that gives us, once you put that in your calculator, you should get 0.43 amps. Please write down any questions that you have so that I can answer them in class for you. And now it's time for you to summarize also, and I want you to do the same thing. I want you to tell me the relationship between voltage, current, and resistance. How do they affect one another? If one changes, what happens to the others? I hope you have a great evening, and I'll see you in class.